Hi viewers, today we want to discuss about dimensions and dimensional formulas. So what are dimensions and what is a dimensional formula? So a dimensional formula, it is an expression showing the relation between fundamental quantities and derived quantities such that whose powers are raised is called a dimensional form. In shortcut, we will say it as DF, dimensional form. So here, it is an expression showing relation between fundamental quantities and derived quantities such as powers are raised is called a dimensional form. So here we take an example. So let us take an example for the dimensional formula. So we take here an example for writing the area dimensional formula. So area, we know that general formula is length into breadth, L into B. So now we can write this as, in dimensional formulas, mass is 0, m to the power of 0. Length into breadth, length into length is L square. And time factor is 0, so t power 0. So dimensional formula for area is m to the power of 0, L to the power of 2, t power 0, where 0, 2, 0 in mass, length and time are called dimensions. They are nothing but they are the dimensions. So we are representing a derived quantity in terms of the fundamental quantities and whose powers are raised. That we call it as a dimensional formula. Now we have the next one is volume. If we take volume, volume is equal to length into breadth into height. So here also we can write it as mass term is 0, m to the power of 0, L into L into L, L cube, and time is 0. And we have next density. So density is equal to mass by volume. So mass by volume, so mass is m to the power of 1. So volume just we have L to the power of 3, it goes up, L to the power of minus 3, and time factor is 0. So the dimensional formula for the density is m to the power of 1, L to the power of minus 3, t power 0. So not only this, you can write any dimensional formula. So for example, we have for speed, so speed is equal to distance by time. So distance by time. So distance is L, by time is t. So we can write the dimensional formula as m to the power of 0, L to the power of 1, t power minus 1. And also for the velocity also same dimensional formula. In place of distance, we take it as a displacement. So speed and velocity have the same dimensional formula, m to the power of 0, L to the power of 1, t power minus 1. So if you know that velocity or speed, now we can go for the acceleration. So acceleration is nothing but velocity by time. So velocity by time. So velocity just now we have m to the power of 0, L to the power of 1, t power minus 1. By time is t. So implies m to the power of 0, L to the power of 1, t power minus 2. So this is the dimensional formula for the acceleration. And not only that, if you know the acceleration, you can write force. So force is mass into acceleration. So mass m to the power of 1, acceleration L to the power of 1, t power minus 2. So if you know the force, now you can write work. So work done is force into displacement, F into S. So m to the power of 1, L to the power of 1, t power minus 2 into displacement is L to the power of 1. So m to the power of 1, L square, t power minus 2. So this is the dimensional formula for the force. So if you know force, now we can go for this work, and afterwards we can go for the power. So power is equal to work by time, W by T. So work done, just we have m to the power of 1, L to the power of 2, t power minus 2 by T. So this is equal to m to the power of 1, L to the power of 2, t power minus 3. It goes up. So students, you can write the dimensional formulas. Whatever physical quantities you have in physics, if you know the general formula, automatically you can write the, what you call this, dimensional formulas. So when we know these dimensional formulas, how to write, now we go for we have this, what are the uses of dimensional formula? So uses of dimensional formula. So we have the three important uses for the dimensional formula. So first one is to check correctness of a given equation. So whether the equation is correct or not, to check the correctness of a given equation. So we use the dimensional formulas to check the correctness. So one example we can take. So we want to check the famous equation of motion, v is equal to u plus at. Whether this equation is correct or not. So we take left hand side. We have velocity. So velocity is final velocity. Dimensional formula is m to the power of 0, L to the power of 1, t power minus 1. And right hand side. So initial velocity u plus at. So u is again m to the power of 0, L to the power of 1, t power minus 1, plus a acceleration m to the power of 0, L to the power of 1, t power minus 2 into t, so t power 1. So now if we take the RHS, then we have m to the power of 0, L to the power of 1, t power minus 1, plus here minus 2 minus 1 plus 1. So we have m to the power of 0, L to the power of 1, t power minus 1. So if you add, you will get 2 m to the power of 0, L to the power of 1, t power minus 1. This is the RHS we have. So here, this 2 is a number. So number does not have any dimensional formulas. So therefore, so LHS, m to the power of 0, L to the power of 1, t power minus 1 is equal to RHS. Hence, the above equation is correct. So this is the one of the usefulness of the what you call dimensional formula. That is to check the correctness of a given equation. So this is the first use of this dimensional formula. Next we have the second use is to change one system of unit one system of unit to the other system. One system into other system. So we can change the other system by using the dimensional formula to change one system of unit to the other system. For example, you can convert 1 Newton into dynes 10 to the power of 5 dynes. So Newton is unit for the force in SI system, and dyne is the unit for the force in CC system. So you can convert one system of unit to the other system. So this is the second usefulness of the what you call this dimensional formula. Not only that, we have the third use of the dimensional formula is to derive equations containing physical constants. So if you have physical constants in the equation, we can derive those equations, physical constants. So like we have example, we have time period of a simple pendulum, t is equal to 2 pi into root of L by G. So 2 pi is a constant. So if an equation contains a physical constant, then we can use what you call these dimensional formulas and derive that equation. So we have three uses of dimensional formulas. One is to check the correctness of the given equation. Second one is to change one system of unit to the other system. Third one is to derive equations containing the physical constants. So when we know the uses, now there are certain limitations for the what you call this dimensional formulas. So limitations of dimensional formula. So we have limitations for the dimensional formula. So we have first limitation is we cannot apply dimensional formula DF shortcut to numbers and trigonometric ratios. So trigonometric ratios like tan theta, cos theta, etc. And also exponential functions. So exponential functions we cannot apply the what you call this dimensional function. And not only that, if an equation contains more than 3 fundamental quantities, then it is difficult to apply dimensional formula or equations. So these two are limitations for the what you call dimensional formula. You cannot apply dimensional formula to numbers, trigonometric ratios like tan theta, cos theta, etc. and also exponential functions. If an equation contains more than 3 fundamental quantities, it is difficult to apply dimensional formulas. So students, now we have an idea about what is a dimensional formula, what are dimensions, and how to write the dimensional formulas. And also we have uses of dimensional formula and also limitations of dimensional formula. So in this video we have discussed about the above things, and hope we will go for the next video with a little bit another problematic problems we have in JEE mains and NEET about the units and dimensions. So please do subscribe my channel Physics DSR. Thank you.